In the 1800s, in Como, Italy, a physicist named Alessandro Volta took a bunch of zinc and copper, stacked them together, separate by clothes soaked in salt water. Volta noticed that his invention managed to produce a steady supply of current. He just invented the world's first true battery. Volta's battery is a very simple type of Voltaic cell, so simple we can even make a similar one using simple household items. In fact, we will make one today. In these experiments, we will study how the voltage produced in a series circuit depends on the amount of the Voltaic cell. Here's what we are going to do. First, prepare multiple jars and fill them with artificial vernicle. Next, submerge 2 electrodes, the zinc as the anodes and the copper as the cathode in each beaker. Connect the jar alternatively to create a series circuit. Connect both ends to an LED. If the voltage produced is high enough, the LED should light up. The first step is to make the anode and cathode electrodes. For our Voltaic cell, we are using zinc as our anode, which is the negative terminal. It is cheap, easy to obtain and quite stable. We need some old zinc roofing, a Sharpie, and a ruler. Now, we are working with a sharp rusty object here, so it is a good time to put on some gloves. Cause getting tenderness is not fun. Anyway, use the Sharpie marker and the ruler to make a guideline and cut the zinc roof using a variation snip. A variation snip has 4 pivot points which give extra mechanical advantage, making the cutting process easier. In this case, we have cut 2 strips, but look at our strips. Now, if you Google what does pure zinc look like, you will notice it has a nice, shiny, silvery color. Problem is our strips has a boring, dull grey color. This is because this is old zinc roofings and because of the Malaysia weather. So it has accumulated an oxide layer that must be removed. So first, get some water in a container and a medium grade sandpaper. This one is used, but it doesn't matter. Soak the sandpaper in the water and sand the strips. Pro tips: don't remove the grey stuff. It has abrasive property which will help us speed up the process. You can see the difference here. By removing the oxide layer, zinc can release electrons way more easily. This is what it looked like with one side sanded. Sand the another side and the electrode is done. For a cathode electrode, we are gonna to use copper as our electrode. Here, we have some old wires. Now, some wires are like really old. So let's check if the copper inside has oxidized. Use the cutter to remove the insulator. Pure copper has pinkish orange color. This one has a greenish white color, which means the whole wire is oxidized. So let's throw this one and try the another. Aha! The outside of this wire might look old, but the inside are still good in shapes. So we will just use this one. Cut about 8 cm using a plier. Use the cutter to remove the insulation's layer. The copper here are a bit flimsy. Use 2 pliers and coil them together. Remove the oxide part using the plier with a little bit of persuasion, and it should come off. This what's gonna be used as one of our electrodes. Now, if you live in a typical middle-class Asian family, you probably have a cupboard that look like this. Good. We can use the old jar that your parent doesn't want to recycle or throw them away. Find a small or medium-sized jar and fill them with artificial vinegar. First, let's test the voltage produced from only one cell. We are going to assemble a simple circuit with just one cell. Using a voltmeter, we found that one cell can produce about 0.6 watt. That is not enough to light up the LED. we need about 3 watts, so we are going to make 5 cells. So here's a circuit that makes up of 5 cells.
Now do the
next 我们要放这个
okay.
And there is it, the LED lights up. So what is the explanation behind these experiments? Let us discuss about it. Essentially, series circuit is a single path for a current to flow, and the current flow through the circuit is the same. The total voltage of the circuit is the sum of the voltage in the series circuit, and this is same for the resistor. You may ask, what are the benefits of arranging circuit in series? Well, this can help us to save costs by using less wire cable in wiring and supplying higher voltage compared to parallel circuit. Well, this can help us to save costs by using less wire cable in wiring and supplying higher voltage compared to parallel circuit, which is also one of the ways to arrange circuit. This will be discussed in the next group. However, if there is any breaking point in the circuit, the entire circuit will stop operating. In our experiments, we will be using the series circuit in our Voltaic cell. Voltaic cell, also known as galvanic cell, which are common example for batteries. In a Voltaic cell, there are 2 important elements, which is the electrodes and the electrolyte. Electrode is a solid electric conductor that carries electric currents into non-metallic solids or liquid, gases, plasma, or the vacuums. Electrolyte is a compound which produces ions when dissolved in the solutions. 2 different types of metal electrode will be immersed in the electrolyte. In our Voltaic cell, we are using zinc and copper as our electrode, and acidic in the artificial vinegar as the electrolyte. Zinc electrode will undergo oxidation with the half equation, zinc from a zinc 2 plus ion and 2 electrons. Hydrogen ions in acetic acids undergoes reductions with the half equations, 2 mole of hydrogen ions plus 2 electrons to form 1 mole of hydrogen gas. Overall chemical equation is 1 mole of zinc with 2 mole of acetic acids produce 1 mole of zinc acetate and 1 mole of hydrogen gas. In our experiments, we aim to investigate the relationships between the amount of the cells and the voltage produced in the series Voltaic cell. From the data obtained, we proved that the total voltage of the circuit is the sum of the voltage produced in each cell. Hence, this can be concluded as when the amount of cell increase, the voltage produced in the series Voltaic cells increase. There is a wide variety of batteries that are available for purchase, and these different types of batteries are used in different devices. Large batteries are used to start cars, while much smaller batteries can power hearing aids. Overall, batteries are extremely important in everyday life and will continue to serve humans in the far future. And just like always, thanks for watching.